Welcome to our session, and we are still looking at Kirchhoff's laws. This is our second video under the topic of DC theory. So today we are going to look at how to calculate unknown currents and voltages for a circuit that has two supply voltages. And we shall start by looking at example number one, and therefore, or example number one. And the example number one says that using Kirchhoff's laws, determine, this word is supposed to be determine, using Kirchhoff's laws, determine the current flowing through each component given that R1 is equals to 3 ohms, R2 7 ohms, R3 3 ohms, and V1 is equals to 24 volts, and V2 is equals to 29 volts. This is the circuit diagram. We have been told that R1 is 3 ohms, R2 is 7 ohms, and R3 is 3 ohms. V1 is 24 volts, and V2 is 29 volts. Sorry. Remember in our video 1 under Kirchhoff's laws, or video part 1, we started by defining or setting Kirchhoff's laws. That is Kirchhoff's voltage law and Kirchhoff's current law. And we did the basics whereby we said that current flows from positive to negative, or current flows from a high potential to a low potential. Therefore, current will flow in this loop, that is through R1 and R3. Current will flow in a clockwise direction, that is from positive all the way back to negative. And therefore, this means this is our positive terminal of that resistor, and this is the negative terminal for that resistor. The same, this is the positive terminal for this resistor, and this is the negative terminal for this resistor. Therefore, current will flow from the supply all the way to R1 to R3 and back to the supply. And this we shall call it as loop 1. For this other side, we can see that current is flowing in anti-clockwise direction. Remember, we have said that current flows from positive to negative. Therefore, this is our positive and it is going in this direction. Therefore, our current will flow in anti-clockwise direction. That is from our supply voltage 2 to R2 to R3 and back to the supply. So this means this is our positive terminal for this resistor, is a negative terminal for that resistor, this is a positive terminal, and this is a negative terminal. Therefore, in this loop, current will flow in anti-clockwise direction. Let's label this as our loop 2. This is our loop 2. So this is our loop 2, this is our loop 1. Remember we said that using Kirchhoff's law, we have to be familiar with those two laws for us to be able to form the equations. And remember, when working on the equations, if you mess up on one equation, then it tells you that you will not get the answer correct. I hope we are together up to that point. If we mess at any given point of any equation, that tells you that you will not get the right thing. Therefore, we know that using Ohm's law, that voltage is given by current multiplied by resistance. Ohm's law, voltage is given by current multiplied by resistance. Therefore, our voltage drop from this resistor here will be, this is our current 1, current that is flowing through this direction is current 1, or current I1 through R1. Therefore, our voltage will be given by I1 multiplied by R1. And R1, we have been told from the question, is 3 ohms. Therefore, voltage drop across this resistance will be 3 I1 volts. Voltage across this resistance here, R3, will be, this resistance we've been told is 3 ohms, and current flowing through this resistance is I1 plus I2. Why? This is the reason. We say that using Kirchhoff's law, the sum of the currents flowing into a junction is equals to the current flowing out of the junction. We say that using Kirchhoff's law, that current flowing into a junction is equal to the sum of the currents flowing out of the junction. If you look at this diagram here, we can see that I1 is going to the junction, I2 is also going or flowing to the junction. Therefore, the current that is flowing out of the junction will be given by I1 plus I3. And this is the current that is going through our resistance R3. Therefore, the voltage drop across this resistance will be given by, our resistance here we have been told is 3 ohms. So, we shall multiply 3 ohms by this current. So, we write 3 and open brackets, I1 plus I2. Then you close the brackets. Or in other words, you can say that this current here is the same as I3. You can as well write I3. There shall be no penalties for that. Let's start solving the equation. A solution for that, we shall see that we have said that current 1 is plus current 2, we get current 3. And this is our current 3, the one that we have said is I1 plus I2. So that is our first equation. The second equation, we get it, or we develop it from loop 1. And loop 1 is here. Because this is our supply voltage V1, this becomes our loop 1. And because this is our supply voltage V2, then this loop here becomes loop 2. Now, remember we said that current flows from a high potential to a low potential. Therefore, this will be positive 24. This is positive to negative, that is a negative voltage drop. Therefore, will be negative 3 I1. This is 3 I3. Therefore, from positive to negative, that is a negative voltage drop. Therefore, we shall have negative 3 I3 volts is equals to 0. Let's look at what we have here. We shall have positive 24 minus 3 I1 minus 3 I3 is equals to 0. When this moves to this direction or to this other side, we shall remain with 24 is equals to 3 I1 plus 3 I3. That is our equation number 2. Let's look at equation number 3. At loop 2, this current is moving in anti-clockwise direction. Therefore, this is positive terminal of that resistor and this is the negative terminal of that resistor. This is the positive terminal of this resistor, this is the negative terminal of this resistor. Therefore, the voltage drop across R2 will be given by 7 ohms multiplied by I2. And current across this resistor, we had already find it, that is 3 I3, or 3 into brackets I1 plus I2. Therefore, let's develop the equation. We shall have from, this is positive 29, from positive to negative, that is a negative voltage drop. Therefore, we shall have negative 7 I2. From positive to negative, remember I said that current is flowing in this direction. Therefore, we shall have negative 3 I3 is equals to 0. Let's see it in this way. At loop 2, you say that positive 29 minus 7i2 minus 3i3 is equals to 0. When this crosses to this other side, we shall have 29 is equals to 7i2 plus 3i3. This is our equation number 2. Now let's rewrite the three equations so that we can be able to simplify further or substitute anyway. So our equation number 1 was this: I1 plus I2 is equals to I3. Equation number 2, we have 3I1 plus 3I3 is equals to 24. And equation number 3, we have 7I1 plus 7I2 plus 3I3 is equals to 29. Now, if you look at these two equations, that equation 2 and equation 3, we are not in a position to solve it. Why? Because we don't have like terms here. We have 3I3 is common, but on the other side we have I1 and I2. Therefore, we have to eliminate one or substitute one for us to have either I1 to work with either I1 or I2. Now, let's look for I2. Let's work with I1. So therefore, using equation number 1, I2 will be given by I3 minus I1. If I1 moves to this direction, if I1 is taken to this other side, I2 will be given by I3 minus I1. It is here. I have written it for you. I2 is equals to 3, I3 minus I1. Now, let's substitute this in our equation number 3. So we shall have 7. I2 we have said is I3 minus I2 we have said is equals to I3 minus I1. Therefore, we are replacing I2 with this. So we shall have 7 into I3 minus I1, close the brackets, plus 3i3 is equals to 29. Let's open the brackets. We have 7 multiplied by 3i3 is equals to 7i3. 7 multiplied by negative 1i1, negative I1, we shall have negative 7i1. Then we had 3i3 is equals to 29. We have like terms here, that is 3i3 plus positive 7i3 plus 3i3. So we add the like terms. So 7i3 plus 3i3 is equals to 10i3. Then we have negative 7i1 is equals to 29. So that is our equation number 4. Now we can now work with equation 2 and equation 4. Let's rewrite equation 2 and equation 4. We have seen that equation 2 is equals to 3i1 plus 3i3 is equals to 24. This is equation 2, and this is equation 4. Now let's use either substitution method or elimination method, any method that you're comfortable with. You can either use elimination method or substitution method to look for I1 and I3. This is for equation 2 and equation 4. Let's rewrite them. So equation 3 we have said is that 3i3 plus 3i1 is equals to 24, and equation 4 was 10i3 minus 7i1 is equals to 29. Now, for my case, I will use elimination method, and therefore I'll open brackets for this. So we shall have, I want to eliminate I3. Therefore, in equation 2, I will multiply by 10, and equation 4, I'll multiply by 3. Therefore, I will have 10 multiplied by 3i3, I shall have 30i3. 10 multiplied by positive 3i1, I shall have 30i1 is equals to 10 multiplied by 224, I shall have 240. Then we have 3 multiplied by 10i3, we shall have 30i3. 3 multiplied by negative 7i1, we shall have negative 21i1. is equals to 3 multiplied by 29, we shall have 87. Let's confirm. Remember, you can as well pause the video and try to work on your own and see whether we shall have the same answer at the end of the video. So I want to eliminate I3. So here I have positive 30 I3 and also positive 30 I3. So I'll substitute the equation. I will minus the two equations for me to be in a position to eliminate I3. So positive 30 I3 minus plus positive 30 I3. This will be equal to 0. Therefore, I will have eliminated I3. So I will be remaining with I1. So we have positive 30 I1 minus 21 I1. Remember, when a minus sign is followed by a minus sign, it becomes addition. Therefore, I will have positive 30 I1 plus 21 I1. And this one will give me 51 I1 is equals to 240 minus 87. When you take your calculator, you key in 240 minus 87, we shall have 153. Now, I want to look for I1. Therefore, I will divide both sides by 51. So by 51, by 51, by 51. 51 by 51, I'll remain with I1. 153 153 divided by 51, I'll have 3. So I1 will be 3 amperes. My I1 is equals to 3 amperes. Now, you can work with any. You can replace this with either equation 2 or equation 4. Let me work with equation 2. So equation 2 was 3I3 plus 3I1 is equals to 24. I have seen that I1 is equals to 3 amperes. Therefore, I replace 3 amperes with I1. So 3I3 plus 3 multiplied by 3, this we have said that I1 is equals to 3. So instead of me writing I1 here, I'll write 3. So we shall have 3I3 plus 3I3 plus open brackets 3 multiplied by 3 close the bracket is equals to 24. Therefore 3 times 3 is 9. So we shall have 3I3 plus 9 is equals to 24. Now let's take 9 into the other side. Let's take 9 into this side. We shall have 3I3 is equals to 29. 24 minus 9. When you take your calculator and take 24 minus 9, you will have 15. Therefore, 3I3 is equals to 15. Let's look for I3. Divide by 3 both side. So we shall have 3 by 3 will cancel is equals to 15 over 3. Divide by 3 here, 1 divided by 3, 5. Therefore, I3 will be equals to 5 amperes. I3 is equals to 5 amperes. Now, we already have I1 and I3. And remember we said that I2 is equals to I3 minus I1. Therefore, using I3 and I1, we can get I2. We have said that I3 is equals to 5 amperes and I1 is equals to 3 amperes. So 5 minus 3, we shall get 2 amperes. So our I2 is equals to 2 amperes. Let's prove and see whether we have the correct answer. Let's prove and see whether we have the correct answer. We have said that I1 is equals to 3 and I3 is equals to 5. Let's prove using equation 2 and equation 4. So you shall open your brackets and say 3 multiplied by 3 plus 3 multiplied by 2. 3 I3 is 5, sorry. Let me repeat that. So using equation 2, this is our equation 2. So we have seen that I1 is equals to 3, so we shall have 3 multiplied by 3. 3 multiplied by 3, close the bracket, plus we have I3, we have seen is 5, so we shall have 3 multiplied by 5, close the bracket, then it's equals. I'm getting 24. You can also prove. Let me prove the second equation. Okay, the second equation is I'm using I2 and I3. I've already worked out for I2, so I shall have 7 multiplied by 2. I2 is equals to 2 plus 3 multiplied by 3. We have seen I3 is 5. Then you close the bracket and I'm getting 29. So you can as well prove. So if you multiply this current by the resistance plus this current by the resistance, you are supposed to get this supply voltage here. That is 3 I1, 3 multiplied by 3 I1. I1 we have seen is 3 and R1 is 3 also. So we shall have 3 multiplied by 3 and the voltage drop across this resistance here will be 9 volts. Then let's look for this. I3 we have seen is 5 and this resistance here also had 3 3 ohms. Therefore, the voltage drop across this resistance here will be given by uh, 5, which is the current, multiplied by the 3 ohm resistor. So 3 times 5 is 15. So the voltage drop across this component here will be 15. Therefore, when you take 9 plus 15, you're supposed to get the supply voltage here, which is 24. The same thing will happen to this other side. The supply voltage here is 29. Therefore, we have a voltage drop across R2 and a voltage drop across R3. When you had these two voltage drops, you are supposed to get the supply voltage. R2 is 7 and I2 is 2. Therefore, 7 multiplied by 2 is 14. This one we had already seen is 15. So 14 plus 15, you're getting 29. Then that means we are correct. Now let's look for this assignment. Remember, in my class, we can never miss an assignment. And therefore, this is an assignment for you. We have this diagram here. We have R1, R2, and R3. And the question says that using Kirchhoff's laws, calculate part A, the current flowing through each component. Using Kirchhoff's laws, calculate the current flowing through each component. And part B, determine the power dissipated in the resistance R or R3. The resistance R3, yes, resistance R3, given that V1 is equals to 30 ohms, 30 volts, 30 volts or volts, and V2 is equals to 10 volts. R1 is equals to 2 ohms, R2 is equals to 3 ohms, and R3 is equals to 5 ohms. So kindly work on that example or that assignment and let it be submitted in our next class. Thank you for watching. May God bless you.